Okay, I think we can start. Okay, welcome. I'm very happy to see this crowd in the afternoon session, which is often a little bit less crowded. Okay, so we are going to spend a couple hours with Flask and advanced patterns with Armin Ronacher, right? More or less. Yeah. More or less. Thank you very much.
Okay, so hello everybody. This time I managed to get to the presenters room. How many of you have used Flask in the past? Perfect. So I was submitting this talk a while ago, and I wasn't really sure what it would look like because you always make up this stuff way too much in advance. So all the patterns that are in here are actually for the really latest version of Flask. But first, sorry again for not being able to attend yesterday. So everything that's in here is for the Flask 09 version, which was released on Friday, I think. Or actually might be Sunday. But in any case, a lot of the stuff is actually not possible with older versions. And which is interesting because the changes are actually very insignificant if you just look over the changelog. But there was a lot of internal restructuring which made a lot of new patterns possible. So what's presented here is not necessarily the best pattern or best practice in a year from now, but I think right now it's probably the way to do things. And I will update the documentation appropriately in the future. But a lot of stuff that's in the documentation was not updated yet for the latest version, just because it affects a lot of really small patterns, which people got used to. So it's a more major undertaking to update the docs. So what's important to understand all of these patterns is how state and context works in Flask, especially with the new version. So if you look at the Hello World example, there are two quite major differences between everything outside the function and what's inside the function. And that's what Flask internally refers to as different states. So if you do a modification, so first of all, in Flask you can create as many applications as you want. They are entirely independent of each other. But in order to customize the application, you do a modification on the specific application. For instance, if I do app route, it registers the function with the application. And everything that you do as modification on the app object is internally referred as the application state. So every modification on there is available for all the requests you're doing on that particular application. What's happening inside the function is the runtime state. And there is a big difference between them because one of them has access to certain things, but the other one has not. And with Flask 09, the request runtime state is now split up in two parts. One is the request runtime state, the other one is the application runtime state. So what does this all mean? Basically, if you work with Flask, you will have seen these proxies like current app and request. They have to point to something. They are proxies to whatever is current. And previously it was if you had an active request, current app would point to something and the request would point to something. With 09, these are now separate things. So the application can even work as the current app can still work if you don't have an active request, if you want to have it working this way. So basically you create an application and current app is unbound. And current app can't know that application is the one it should point to. So if any one of you ever try to do a blueprint thing and then notice that current app is not pointing anywhere, that's because previously it was only possible to have current app point to the correct application if there was a request. Now, however, there's a new thing called the app context. It's very similar to the request context, which is automatically managed for you in a regular request. But if you do app with app context, the current app proxy now points to the application. Likewise, if you do it with the test request context, the request object points to something. So this is basically the big change in 09, that instead of just the request context, there are two now. So why is this useful? So first of all, these context objects, they are actually stacks. So you can nest. If you go back to that example, you can nest multiple of those inside each other. So you could do with app context, and then inside the with statement, you could do work on a different application if you want. All right, so there are stacks, which is useful because what you can do, for instance, is you can make a new request context on top of already existing one in order to implement an internal redirect if you want. And it's really helpful for testing. In general, it's a good idea that it's supported this way. And a couple of patterns require you to actually nest them if you want. So what happens internally in the main Flask Whiskey app, this is exactly the code that's in there, which is basically it makes a request context. And the data for this request context comes out of the Whiskey environment. So this is everything that the browser submits to the application is inside this Whiskey environment dictionary. And the moment you create this request context, it creates the request object and a bunch of other stuff that's useful. At that point, it enters the runtime state. So if the with statement starts executing the body, you have access to the request, and you have access to the session and the G object, where you can store arbitrary stuff for the duration of the request. And then it does a full dispatch, request dispatch, where it tries to resolve the current URL, it finds your function, and then it evokes the function, and so on. If the execution fails, it makes a response of the exception handler's return value. And then it executes the Whiskey app. And the response object that comes back is actually just another Whiskey app. So you can nest them arbitrarily if you want. You could, for instance, return a Whiskey application from your view function in Flask if you want. So this is basically how the core of Flask still works. So you make a request context and it enters it. Now what's interesting is request stack and application stack are independent. So where is the application stack coming from? The application context basically coming from if it's not created there. So they're independent. And you basically manage them normally like this. You can either do it with a with statement, or you can make one, push it by hand, and then finally pop it. And what comes back from the with statement is basically this line, Flask request context stack top, which looks internal, but it's actually documented. So how does the application context come into play here if the request context is the only thing right now? And it's because if you push the request context, you're implicitly also pushing the application context. So when the moment it opens the request context, if it sees that there is no application context, or the application context top level does not match the current application, it implicitly pushes the current application context. And then at the end, it pops the whole thing. So you can see that here, current app is unbound. We make a test request context, and current app points to the app. So implicitly, the application context was pushed as well. And now with that, basically you have the ability to put stuff on the request context separately than you put on the application context. So how many of you are, for testing applications with Flask, currently doing fake requests in order to get a database connection or something like that? Right, at least one person. So one of the things that the old documentation was suggesting is that you could, on the beginning of the request, open a database connection, and at the end of the request you can close the database connection. Which is nice, but the problem is then you can only have database connections if there is an actual request going on. Since requests are quite expensive compared to not having a request, you can now just not use the test request context. So if all you need to do is basically just get access to the current application, to the current configuration, the current database connection, you can just use the application context instead. So if you have these objects, these request objects, these stacks that manage them are Flask underscore request context stack and underscore app context stack. How many of you have used the first one? All right, nobody. So I guess none of you have written a Flask extension or dealt with them. So they were originally intended to be used for Flask extensions only. So internally, so I guess you have used the G object, which is generally used to store things on it. The G object is stored on the request context stack. So you can either modify the G object itself, or you could also go one level down and modify the request context stack. It's similar to sysgetFrame in how it's supposed to be done, There are legitimate uses for them, but you have to be very careful. So when you have a stack, like the request context stack, .top gives you access to the topmost level, which is what's happening right now. And this object is documented as in having a bunch of interesting attributes on it. But everything and every extension can put more attributes on this thing. Like for instance, if you use flask.request to get access to the current request, but the request object in Flask is actually a proxy to something else, and what the proxy resolves to is request context step top request. So this is all the proxies that exist, like G, session, request, all of them point to the request object stack topmost one of the attributes, except for current app, which points to the application context stack. So these stack objects are shared. You can modify them as you want, but you will have to be somewhat creative with the naming of your own attributes, because this is a shared space. This is like one namespace. Everybody can put stuff on there. So if you put like an object called context on it, it's very generic, or connection. So you should call it my application underscore connection or something like that. Okay, so how does runtime state live in general? It's request bound by default, which means if the request comes in, it makes a new request context object. And if the request ends, that object goes away. But you could also push it around your tests. Like if you execute a test, you could push the stack, push the context, execute the test, and then pop the context. And it's controlled by the user, which means you can customize it as much as you want. And they tear down quite early. I'm coming to that a little bit later. But basically it means that if your view function returns a value, the context disappears. So if you manage to execute for longer than your view function is actually executing, what usually happens if you have a generator, then you will notice that the context is already gone. Okay, so this is how it's supposed to be used. On the request context, you put everything that has anything to do with a web browser, like HTTP stuff. The request data, it's on there by default, and the session data, which is on there by default. But if you find anything else that's request related, you put it on there. If it's connection pooling or configuration management or anything of that sort, with 0.9, it's now supposed to go in the application context instead. And some of the Flask extensions were already updated to work this way. Okay, so this is now the first pattern, which is connection management. So this is basically how connection management was documented in the documentation with the latest version. So you make an app, and before a request comes in, you connect to the database, and you do that by putting a connection on the G object. So that would live till the end of the request. Everything is fine. But you would also have to do is because a database is an external resource, you're not controlling it. Like normally if an object in Python gets garbage collected, it will eventually also release the resource that goes with it. But you should be really very explicit. So you can set a teardown handler, which is executed every time the request tears down for any reason, either an exception or because the end of the request was reached. And then you get the database from the G object. And if it's actually on there, you can close it. Now, why would that line be necessary? Why wouldn't I do g.db.close? Well, the reason is that if, for instance, the connection fails, there is no database object on the G object. Like, for instance, if my database server is down and connect to the database gives me a socket exception, that would still execute. So we have to be careful. And if you use getAttr G, then the name of the attribute, in this case, database, and a third parameter, which is the default, which if it doesn't find it, it will pick it. You avoid raising exception there. All right, so what's the problem? What's the potential problem with this pattern? The first one is there has to be an active request for you to get access to the database, which is not very nice. You would just notice that in tests, it's annoying if you have to make test request objects for the only reason being really database access. The other thing is that if you have like a cron job executing and the cron job wants access to the database as well, you would have to make up a fake request for no good reason really. And since it's connecting to the database every time the request comes in, it's going to connect to the database even if you don't want to have a connection to the database, or you don't need one. Like for instance, if I'm rendering out a static HTML page, why would I need my database connection? But it would still connect to it. And once you start using g.db, it exposes an implementation detail, so it's really hard to switch to something else. So this is how you can do it better. And this involves the slightly internal _app CTX stack. Basically, instead of doing a database connection every time and then accessing g.db, you have a function called getDatabase. And that returns me a connection. And the way it works is you get the current context, so you look at the app context stack's topmost level. And then you get the attribute myAppDatabase from it. If that doesn't exist yet, you can connect to the database and then store it and then return the connection. So basically, the first time you call getDB, you get the database object. And it sticks on there for the duration of the request. And then when the app context tears down, not the request context, you get the whole, it's basically the same code as before, just in this case it's the app context, no longer the request context. There is still one obvious problem with this, which is basically, this is just for one application. So if you want to use this with two independent applications, that's not as trivial, because first of all, the decorator is bound to one specific application, and the configuration for the database URL is also coming from that particular application. So in order to do this with multiple applications, this is really then how you can make a Flask extension out of the whole thing, as instead of making the application, you make a function called initApp, which initializes the application. And so before we had the decorator for executing this function at the end. Now the decorator is gone from here and moves up to initApp. So when you initialize the application, it applies the decorator. And the other change is, before it was app_config, now it's ctx.app, which gives me the current application that the context is bound to. And this is how you would use it. So instead of just using g.db execute some operation, you now do db equals getDatabase, and then on the db object you execute the operation. So the first time this function is called, it makes my database connection, and then you can execute stuff on it. Now, the obvious problem with that in that it doesn't look as nice anymore because you call a function. So previously you just did g.db and you had this object. Now you have to do a function call to get this object. But the good thing is that you can use the proxies from Werkzeug internally, and then you do db equals local proxy to the function you want to call, and then you can do db.execute some operation the first time. So every time you do an attribute lookup on the execute some operation, it calls this function, which does the same thing. Which is very simple pattern, but not many people know that you can actually use the local proxies yourself. So basically, if you give this any function, the return value of the function will be what the proxy is pointing to. Are there any questions for this particular connection management thing?
If you go back just one where you had it before, so you just call getDB in the index function?
Yeah.
Like you're actually adding into the namespace too? You don't have to put database.getDB?
Yes, that would have to be your database.getDB.
Okay, so it's not inserting into the global namespace.
No.
Okay, yeah.
No fancy shenanigans, just me missing out the module name here. So it should be your database.getDB. All right, so just a little bit more on how the teardown function works. Because everybody knows kind of that the teardown function is executed at the end of the request, but when exactly is end of the request? So it's actually executed when the context is popped. So if you have an app and you do a teardown function on it, and then you just print out what's happening, you can see that the moment you exit from the context manager, it prints out that it's tearing down. In this case, it's tearing down with no error. Likewise, if you raise an exception in there, it's tearing down with a specific error. So the error is always passed to the teardown function. So what's important about teardown function is they always execute. You can't prevent them from executing. Unless one of the other teardown function in the process of tearing down raise an exception. Then the whole thing just dies. So you have to write the teardown function in a way that they don't raise exceptions. This one would be the bad one. So the G resource release. It releases the resource. It could be a database connection or anything else at the end of the request. The better version is you get it as an attribute from the thing, and you make sure it doesn't raise an attribute exception. You could also take this, and if you want to be really careful, you could just try accept everything, and then you log an error if a teardown handler failed, because it generally means that something went wrong. But you can very defensively just write it that it doesn't raise any exceptions. And since the error is passed to the teardown function, you can be very clever in them. For instance, for a database connection, you could get the database connection, and then if there is no connection, you just don't do anything. But if there is an error, you do a rollback, or if there is no error, you do a commit. So you wouldn't need to do any explicit transaction management. You could just move your whole transaction management into the teardown function. How many of you are using Flask with custom database code, and how many are using it with a ready-made extension like Flask SQL Alchemy or Flask Mongo or whatever is there? Right, so how many of you use it without an extension? Right, how many of you use an extension just to... Right, and I guess the rest is not using a database. Fair enough. Okay, so I would recommend using one of the extensions because they do a lot of really cool management for you in there. But if you would want to bridge to your own database, this is really how you should do it. All right, the next one would be how you can create response objects. For the majority of cases, you don't need to create a response object because they're created automatically for you. So there is always only one request object, which is flask.request. And this is available for you. But response objects are really created by something in the system or by you. And some other parts in the system can replace the response object as it's passed down through to the Whiskey app. And this seems to be very confusing behavior for people that start using Flask coming from PHP or I think even Pyramid. But you have to be aware that there is an explicit response object creation. So Flask request is a current request, but there is no Flask.response. That just doesn't exist. So how do you deal with not having this global response object? So first of all, responses are created implicitly automatically. So render template returns a string. As this function returns, something in the Flask core picks up the return value and makes it into a response. And the default logic is if there is a string returned, I'm going to assume that you mean everything went okay and it's HTML you're sending me. So it creates a response. If you would want to have the response object in your hand and not being created down somewhere in the Flask core, you can use the makeResponse function. So you get the string, the return value from the render template function, or however you do the response. Then you make the response object out of that. And then here you could modify the response object. For instance, you could change the status code on it. And then you can return the response object. Now this is something you normally don't do because there really is no reason to make the response at this level. Unless you actually want to modify a particular attribute on the response object.
Why are you not calling the response object creator directly, but with make response?
All right, so I could also just make a response this way. I make the response object. I make an instance of the response class. That would be possible. And the difference is that this one here goes through the same logic as Flask goes internally with the return value. So you basically put the return value of the function as arguments to make response, and you get the exact same logic as would happen if you would return the thing. You could also just make a response object, but this takes very different parameters. So whatever you want to do, you have different ways to accomplish that. I'm going to assume that for the majority of cases where you want to deal with a response object, you want to call this. So basically, when you call the flask.makeResponse function, what happens internally is it checks what's the current application. And then it asks the current application, how do you want to convert this object into a response? So these are a couple of uses how you can do that. So you can either pass it one argument, which is a string, and you get a response object back. Everything is okay. You get 12 bytes of payload in it. You can also pass a second argument, or you can return a tuple from the function has the same, basically the same end effect, where you get the body first, which is what you return, and the status code as a second argument. So you can get a 404 not found instead of a 200 OK. You can also, the third argument could be a dictionary of headers or a list of headers. And make response is idempotent, and you can also call it with the return value of an arbitrary function, so you can pass it as a tuple with the arguments instead of passing its actual arguments. And you can call it as many times, and it doesn't destroy anything. So you can call make response on an actual response object already. So first call returns a response object, second call doesn't touch it. And the reason why this is very useful is normally I would suggest not modifying any responses in a function. Instead, you do a decorator. For instance, that would be a decorator that adds an X runtime header to all the requests where the decorator is applied, which has the numbers of seconds elapsed for the execution of the request. So you make a decorator. That's unfortunately in Python always quite elaborate because it involves functions within functions. But basically, you take the function, and then you return a different function which wraps the execution of the request. And this is where the request is happening. So it calls the function with the original arguments and keyword arguments, and then it gets a return value and makes a response out of it. Because it's doing that since it doesn't know if the function will return a response or not. And then it can modify the response, like adding a new header to it, and then returns it. And then we do the update wrapper thing to make the function have the same name, the same doc string, and so on. So if you now do add timing information on any of the functions, it takes a return value and puts a new attribute or a new header on the response object. This is also what you could also customize the make response. So if you have an API, you could return actual objects from your functions and have them be converted into actual HTTP responses. The reason why it's really helpful to not return response objects from your functions, but to return like the lower level things that would be string, or the higher level things that would be strings or tuples, is that you can call them easily in a test and see if the return value is what you expect, and you don't have to deal with the response object directly. So for instance, you could customize Flask that you can return arbitrary objects. So you could return user42 John, which would be just an arbitrary user object, and then it has a toJSON method that makes it into a JSON thing. So like a dictionary in this case. And then you have a subclass of Flask, which has a customized make response method on there. And then it checks if the return value has a toJSON argument, it makes a JSON response out of the JSON that comes from the object. What's nice about that is that you can return an arbitrary object and you get a proper HTTP response from it with JSON data. But you can also in your code call the index function yourself and you get the user John back. So you don't get the response, you get the higher level object for further modifications. So you could write decorators on the thing that operate on the object and they don't operate on the response. So for instance, you could have if you return dictionaries with JSON data, you could have decorators that remove unsafe elements from the response. For instance, you could return a user's information, but in the decorator you're checking that if the user you're returning is not the user of the current request, you remove the email address, for instance, because you don't want to expose someone else's email address. So by having this ability to return, to modify into an actual HTTP response at a different level, you can use decorators to do modifications that are not operating on responses. They are operating on other objects. Has any one of you done anything like that in Flask? All right, one. Are there any questions for this particular use case? All right. Yeah.
Wait. Where are you?
Never mind.
Never mind.
I guess the question is, can you do something else with it? Yes, because you wrote the code up there. So it can be just 2 XML, and if it has a 2 XML, you're under XML. What you could also do is you have 2 internal representation, which is what we're doing in a sense. and then we get the dictionary back, and then we check the current request object, what's your accept header, and depending on if you want JSON back or if you want XML back, we give you something else. We're not actually supporting XML, but same concept really.
Sorry, I'm distracted by the radio.
Okay. Hi, this Flask.make underscore response, does it use the response class of the specific Flask
Yes.
application?
So if we go back to this one here where it does from Flask import response, you can change the response class on the Flask application. So you could have app.request underscore class equals my subclass of response, and this is then what also this one is picking up by default.
Okay, cool.
So you can have your own custom classes, response classes, which customize the behavior on a different level. All right, so blueprints, which is the thing that we replaced like 3 times, and we're still not happy with them, but I think they're the most reasonable solution currently, and here's why. All right, so here's the problem. You want to have more than one application. And you can really easily do that in Flask because the applications are independent. So if you compare it to Django, for instance, there is django.conf.settings, and there is only one of them. So you can't have 2 applications independently in the same Python interpreter because there is only one setting thing. Since the settings for Flask are stored on the actual application object, you can easily have more than one of them. So unless you restrict yourself to using only one application, you can use as many of them as you want. But what if you want to share things between applications? Like, what if you want to have 2 applications that are exactly the same, but they only have a different configuration? So how would you do that? Or you would want to do the same thing, but you want on one of the applications one additional function. So app 1, app 2, how does it really work? The problem is it doesn't really work. So attempt 1 would be you make an application, then set the global application currently, like the current app is that application. Then you import all the views so that they register on that application. And then you make a second application, import all the views again. Like that was what you would do in C or in PHP. You would do an include, and it runs again on your code again, execute everything for that app. Then you bind the other app to the name, execute the code again, and you have everything on there. But it doesn't work in Python. The reason it doesn't work in Python is because Python modules are imported in something like an arbitrary order. So you can't really predict in which order modules are importing unless you're really careful. Because Python modules are cached, and the dependency of the modules is resolved at runtime. So the only other option you would have is like you make the app, and then you deep copy the app and modify the second version of the app. But if you use the copy that's actually a good suggestion. Don't use copy.deepcopy. It by design doesn't really work, and if it works, it's really slow. We found out that if you have a small dictionary of just a dictionary of strings and lists in there with an overall size of, let's say, 5 items in there, it's faster to make it into JSON and to decode it from JSON than to use copy.deepcopy. So just don't use copy.deepcopy. It's really not fast. And it's also, the moment it hits a custom type, that custom type has to support deep copying as well. If it doesn't even tell you that it didn't deep copy it in all cases. Sometimes it just tries to and then not necessarily succeeds. All right, so attempt number 2 would be what our test suite is doing basically. You create a function you create the application within a function. So you have a function called makeApp. You give it the file name of the config. Then you make the app in there. You import the config. You have in the function, you make the view function, and then you return the app. And then you can just make as many of them as you want. All right, the problem with that is the functions are now defined locally. So you can no longer import them and call them. They just are somewhere hidden in another function. Technically, there are ways to get access to them, but not really good idea. Pickle can't find those functions either, which doesn't seem to be a major problem, but then you want to do something like a message queue where you say, execute this function for me later on, then you want to pickle the function. So you can't do that anymore there either. Now everything in your file is indented one more time. If you already have problems hitting the like 80 character limit in a line, that makes it worse. And then you actually have multiple copies of the function in your memory. Like this creates not only the app twice, it also creates the function twice. So you now have twice the amount of memory wasted for the function. Technically, not all of the function is in memory twice, but enough that it's annoying. Because you can, if you do like deep introspection, trying to find out things about your Python interpreter, you will see this function is showing up twice. That's weird. All right, so how do blueprints fix that? And the reason that the way they fix that is basically a blueprint behaves similar to an application without all the parts that are the actual application. By that I mean you can call all the modification functions on the blueprint that would also be on the application. So instead of doing app route, you can do blueprint route. And then the blueprint remembers that later on, when you register it with an application, it should execute this against the application. So the blueprint is, as the name suggests, it's a blueprint for making an application. It's not in any way an application. It's just how you make one. And then your make app is reduced. You make the app, you get the config, and then you register the blueprint, and then you have an app. The function you can still call. It's on the global level. It still behaves the same way as you would want, and it's only in memory once, except for the application being there twice. You could argue that it's ugly, and if you have a better solution for this general problem of supporting more than one application, please come up with good suggestions. I think out of the solutions that are in Python frameworks right now, Flask ones might be one of the better ones. At least you can potentially do everything. You might just have to dive a little bit into blueprints to customize them further. So as the name suggests, you can record instructions for the application on the blueprint. So if you do blueprint route, it remembers when you register with the application, do the routing. But you can also record your own instructions for the application. For instance, you can register a function with record once that is executed if the blueprint is registered. And then this function executes. And this function is passed an object called the setup state. And really all you have to know is that on the setup state there is an app object. And then you can customize the app object to your liking. So if you register this blueprint, it will register a global changer variable on the app. It's very useful if you have an extension, a Flask extension, and you want to extend it with additional changer filters or changer tests, or you want to change the config or something. You can do that by just doing this record once, executed function, and it's then executed. The reason why it's called record once and not just record is that this will only execute once. So if you register the blueprint more than once on the same application, this one will only be called the first time. Sometimes you want to write a blueprint that can be registered on the app more than once. There is an example afterwards, which is basically you have a route on the blueprint which returns the resource for a certain user. And then you can register the blueprint at /username. So this is an arbitrary username. So you get a different resource for each user. And the user is then passed to the index function. But you could also register a second time because the admin is special. So he wants his own URL. So you can put it at /special/admin and then say the default here is that the username is the admin. So then if you generate the resource, the URL for the resource for the user Peter, it would be at /Peter. But if you generate the resource for the user admin, it would be at /special/admin. This is also very useful if you do internationalization, because you can put arbitrary things in there. If you do internationalization, one of the downsides here is the username is now passed to every single function as first argument. Well, not as first argument, but you have to have the username accepted in each function. Could be quite annoying to deal with, especially if you would do this with the language code. Imagine the language code is in the URL, and every single function would have to accept the language code. Especially because the function most likely will not have to do anything with the language code. You will most likely handle the language code in a before request handler. Like you would get the language code from the URL, and then you would update your current localization information with the language for this request is this one here. So this is where the URL value pulling is coming in. You can have a function called URL value preprocessor, and there's another one called URL defaults. And these two in combination can be used to modify what is passed to your view function. So URL defaults is called whenever you do a URL for call. So if you do URL for index, you would have to define what language code is in there. So you basically do URL for language code equals English, and then you get /English. But you can also do add arbitrary additional language, additional parameters into your URL for call. So what we do with the URL value preprocessor, this is called before the function is called. It will get out of the values the language code and will put it on the G object. So it's no longer in the values. So the index function is no longer called with the language code. Now, if you want to do URL for, we will put the language code back into the values if it's on G, which makes it really easy because you no longer have to deal with the language code in every single function. The language code is now handled once for you and stored. Are there any questions for this particular pattern? All right. So the more extended version of this would be getting rid of the URL values. So it's basically the same thing. I just renamed language code section. And what we then do is we register the blueprint with the section help. So URL defaults has the section help in there. We register the blueprint a second time with the section FAQ. And then we have a specific URL prefix. So nothing in the URL ever mentions that the thing section exists. It's hidden away. But it's still passed through like everything else. So when the function is called for the URL value preprocessor, it gets a section out of the URL values and puts it on the G object. And then when you generate the URL, it puts it back in. Which is a very abusive way because you're basically using the URL routing system to pass through arbitrary information. But it's very natural in how it works. And I've used that before. It's actually a really nice solution once you get used to how it works. Correct. There should be section. Yeah, it's pretty just copy-paste. Okay, so nobody here has written an extension, I guess, so why not? They're actually really fun to write because the majority of the extensions are not doing anything besides bridging to something someone else already wrote. And in the process of doing that, you can make the API nicer. So if you're always being annoyed by using, you have this really cool library, but it has you use it because it's good, but the API doesn't fit your needs, or it's just too cumbersome to use. With a Flask extension, you have to change to improve the API. All right, so extensions are very vaguely defined. And extensions do not use a plugin system. And they can modify the application in any arbitrary way. And you can use whatever you want to do to accomplish your goal, with the obvious end result that you cannot unregister an application and an extension once it's on the application. But that's fine, because you can just throw away the whole application and then make a new application object and only put the extensions on there you actually want to use. So if you have a Flask extension, I guess you have used one. It's the general pattern is from the Flask extension, you import something. It's usually a class with the same name as the extension. And then you can either pass it the app directly and you get the extension instance back, or you can make this extension instance and then initialize the application with it. Now, there is a huge difference between the first one and the second one, and Flask extension is supposed to support both of them. And I'm coming to what's the difference, but can you guess what's the difference between them? Any good suggestions? No guesses. All right, so the difference is basically if you create a function, if you create your application within a function, you still want your extension to be global. And the reason why you want your extension to be global is because something is going to use that. Something is going to import the extension. Otherwise, you have to pass it to every single view function. It would be very annoying. So what the first one is doing, it says, I make an extension, and it's for this application. In the second case, I make an extension, which I can later on use with arbitrary number of applications. So the first one has the attention, this will always only be used by this particular application. And you will not be able to use it with any other application. In the second case, I can put as many applications to the extension as I want. So we started using Flask extension in the Flask X namespace package. And it turns out that pip is not particularly good at handling namespace packages. So the new pattern is you call your extension Flask_extension name. And since the extensions are moving over to the new import system at an arbitrary point in time, and you can't really control that, you can now use from flask.x.foo import something, and it will try the first one and it will try the second one, and whatever succeeds, it will pick up. So you can generally just use, if you have a Flask extension, you can generally just use flask.x, name of the extension, and the import will succeed, no matter which distribution model is picked.
Since 0.9.
The redirect import is there since 07, I think. For a while already. I think it's somewhere last year. Okay, so basically, yeah, this is the difference. App passed to the constructor is a singleton. App passed to init app. You can have as many of them as you want. All right, so this would be the intended simple usage of this fake extension we're making here. You import Flask, you import your extension, then you make an app, then you make the extension, and pass it the app. So we're using the first pattern here, which is this extension is only for this app. And then in the function where we're using the extension, we use this extension and get the connection and then get the cursor and then execute stuff with it. So this would be the bad implementation, but it's very simple. If you pass the app to the constructor, you're basically assuming it's the same thing as if you're calling init app, and then you provide some defaults into the configuration. Like by default, we want to use the database in memory, so you can still override it. And then we execute a function at the end of the app. And then we remember what app we're using. So obviously you can't use this extension with more than one application because the application that comes second wins, because we're overriding the first app. The teardown function is correct. It tears down properly. And then there is this property on the connection. And it gets the current context and checks if there is already SQLite database connection stored on it. If not, it connects to the app config's database, and then it returns the database connection. So the better version of this is supporting more than one application. And if you want your extension to be approved within the Flask extension approval process, you have to make sure that it works with more than one app. So the new version, this actually still not correct because self.app equals app shouldn't be here, is you put this one basically didn't really change. All of these are the same, just self.app equals app, that line is incorrect. Just ignore that one. So we're no longer storing the application on the instance. And the connection is no longer using self.app, it's using context.app. So it works with arbitrary number of applications because we don't have to remember them. We always use the application context to figure out what's the current one. So now what you can do is basically the same thing. You have your SQLite thing, you have a blueprint, you execute something with it, and then you make your app, you update the app config, you register the blueprint, then you initialize the extension down there, and it still works. So the blueprint can use the SQLite object you have created up front, but the app is registered with it later. And then you can still make more applications and go on. Okay, so if you have no longer an app stored on your instance of the extension, you sometimes still have to bridge application config data and your extension config data. And this you can do by using the app.extensions attribute on the Flask extension object, on the Flask object. So for instance, in the init app, what you can do is you can get the app extensions dictionary and add a new entry for your own extension. In this case, we put a configuration data onto this own entry, which we control. So every extension is allowed to put arbitrary stuff onto a specific place on the application. And then if you call the function, you can get the current context app. Then you get to the extensions, and you can pick out this configuration value again. Yes?
Don't you feel that this app extensions dictionary might explode if you get a lot of extensions and a lot of configuration for them?
Yeah, it will, but every extension has its own key. So it doesn't really matter. It's not supposed for you to look at. It's just that everything puts its stuff in there. And it's really the only thing that works. But it's very useful for a couple of extensions. For instance, Flask SQL Alchemy has to maintain two configurations. One is for Flask, the other one is for SQL Alchemy. So if it bridges those two, it's basically using this extension thing. So have you used SQL Alchemy without Flask at any point in time? All right, so there is this session object, which stores basically the current transaction status. And the session object usually is also used with a factory that makes a session object. So Flask SQL Alchemy stores this configuration for how to make sessions in this extension dictionary. So I can make as many of them as I want, and it still works. So this is how in Flask SQL Alchemy, you make the app, you make the SQL Alchemy object, and then you have this database object where this is actually quite interesting because the database object is a class, it's an instance of a class, but it also has all the attributes of the SQL Alchemy module copied onto. So you don't have to do SQLAlchemy.column, you can do db.column because we put all of the attributes onto this magical object. And what's actually happening here, if you do user.query.all, this user.query is coming from SQL Alchemy, which will try to find the current session, and then it will find through a whole bunch of operations. It will eventually end up consulting the application for the current configuration settings that are in SQL Alchemy, which is very cool because I think we're one of the first Python libraries that actually supports this using the same model for different applications. So it works really well. And it's basically powered by this whole concept of bridging an extension and the application independently. All right, so this one is. Are there any questions for extension development? Since there is so much time at the end, anyways, feel free to just walk up and ask random questions for particular problems you might have, because I'm quite interested in seeing where things don't work as good as they should. So for extending the context lifetime, which doesn't really happen very often, but there is a function in Flask now which allows you to do that. Basically, by default, the context stops being alive the moment the function returns. And there is one exception to that. If you have an exception raises in your view function, we will keep the context around for the next request as well. So you can actually connect. If you use the debugger, you can still access all the current request data, despite the fact that the request already ended. And that's basically the reason why this exists. So if you stream data, sometimes you want to have the context around. So this function here, is new with the latest version of Flask, which is you can pass it in generator, and while it's generating over this generator, you still have access to the context. So if you have like a 10 gigabyte file you want to generate, you will run out of memory if you do not stream the data. So if you start streaming this whole thing, and after 10 megabytes of data you want to access the request object, it would be gone if you're not using this function. But you don't have to type this because this already exists within Flask. But if you want to use an older version, you probably want to copy this one. This pattern is actually not Flask related really, but it's very useful. What I see that a lot of people are doing is they store redemption tokens in a database. For instance, you want to activate your user account. So you generate a random token, you store it in a database, then you send a mail, and in the mail there's this link where you can follow, and then you copy your redemption token onto the website, or you follow this unique link. And then it goes to the database, deletes the token, and executes the action. Or if it doesn't see the token in the database, it will present the user with an error. You already redeemed that token. So that's basically always being used for activating user accounts, resetting passwords, that sort of thing. But actually, you don't have to do that. And the reason why you don't have to do that is you can also sign it. So you have a secret key. And Flask's applications already have a secret key anyways, because this is how the sessions work. And then you can just cryptographically sign the link. So there's a library for this. It's called It's Dangerous. And the usage is really simple. You make a URL-safe serializer, and you pass the secret key of the app. And then you have another secret key, which is the salt. So for every different usage of this serializer, you have a different salt, basically. So for activation links, this is the salt. How do you get that? Basically, you call OS urandom and then give it a random size, like 20 bytes. It will spit out a bunch of random bytes, and then you can copy this into your code. And then if you do this, generate this activation link, you have the code. And normally you would generate like a random number stored in a database. Instead, what we're doing is we're dumping the user ID, and the salt is this one here. So if you activate, if the user goes to the activation page, we load the code again. If it's a bad signature, it means the user tampered with the data, so we return a 404 because the link is not valid. Otherwise, we activate the user with this particular ID. There's nothing you have to store in your database. It's very efficient as a result of that. And there is one problem with it. The links only expire the moment if you change the secret key or the activation salt. So you can't revoke a particular user's key. But if you're okay with that limitation, then go ahead. Yes, you can expire the link based on time. So you could, instead of just storing the user ID, you could store the user ID and the current timestamp. And then you can figure out when the link was created. And if it's older than, I don't know, 2 hours, you could just accept it as, I know it's valid, but you were too late. So you can put expiration information there. What you could also do is, like, for instance, we have this password reset page. And if you don't know your password, we want you to be able to get a mail and click a link, and you can reset the password. So we have to expire this link, because if you reset the password and you get this token, but you also manage to sign in the meantime and change your password, otherwise you don't want people to be able to still use that token to reset your password. So what we're doing there is we're putting the MD5 hash of the password hash into it. Actually, a small portion of it. So every time the password changes in the database, all the links that were issued automatically becomes invalid because it no longer matches. You can also, for user activation, for instance, the link automatically no longer works if the user was already activated, because you're checking if it was activated. All right, last thing is really not a pattern. It's just reduce complexity. Don't build monolithic code bases, because otherwise you will not enjoy Flask at all. Make really small components and then find interesting ways to combine them. I can probably show later on in person interesting examples of how we do that in our company. And so embrace service-oriented architecture. It used to be this buzzword which everybody was hating. It doesn't work anyways. But for web applications, it's actually really useful to have small parts, have them work independently. You can rip out individual implementations for a better programming language, or you can just switch out for a different web framework if you notice that you're hitting a limit or something. And it works really well for APIs, and if you're not building APIs, I would argue you're doing it wrong. And so this is how you do it. You write an API first, then you write a JavaScript UI for your API. And then if you, for some reason, can't deal with the fact that you just have written a JavaScript API, you make a server-side version of the parts of the JavaScript UI that are necessary. I already brought up this example a couple of times, but I think it's a really good one. And I don't know if people from ESN are here, but Battlefield 3 has this website where you can join the game from within the browser. And if you, it's actually, but now it's open for the world, so you can also look at it if you don't have the game. But go to battlelog.battlefield.com and look at how it works. It's actually really amazing. Everything is JavaScript driven. But on the initial page load, you get HTML back. And the reason it works for them is because they have their templating system or the UI system written to also work on the server as well as the client. So if you don't have JavaScript, the consumer of the API is running on the server and is generating HTML, which is it's a really cool concept. And it works really well.
Sorry. I think there is the change with someone need to come here or go to another. Or can we switch the make I don't know like 5 minutes to restart the process?
Yeah,
and,
it's the last slide anyway.
Okay,
so
perfect.
You can just move
okay,
the
great,
Q&A.
great. Thank you.
All right. So bonus. Ignore performance concerns. Just focus a little bit of scaling and choose whatever you're happy with using. That's basically my suggestion for building stuff. Smaller pieces are always more fun to work with than really long piece of code that after 2 months you don't really like anymore because there's so much craft in it which just doesn't work anymore. All right. Thank you.
Okay. Sorry for that because we need to restart the process with the presentation and everything.
Yeah.
About password reset, I have facebook.com/Larry. I get several hundred password requests